Hello friends, in this video we are going to quickly revise the subject soil mechanics. Soil is produced by disintegration of rocks. There are two types of soil, which are by erosion and by transportation. By erosion we have physical weathering or chemical weathering, and by transportation we have five types here, which are alluvial deposit, that is by river, lacustrine, by lake, marine deposit, by sea water transportation, airborne deposit by transportation by wind, glacial deposit is by transportation of ice. Now, regional soil deposits in India, there are five types: alluvial deposit, black cotton, laterite, desert, and marine deposit. Now, black cotton soil is very important feature in soil mechanics because it contains morillonite, which is very useful as it has excessive swelling properties. Basic definitions in soil mechanics. First of all, we have to understand the phase diagram, which contains air, water, and solid. Right side we represent the weights, and left side we represent the volume. Volume of void, that is volume of water, and volume of air present in the soil. Void ratio is the ratio of volume of void upon volume of solid. Porosity is the ratio of volume of void to the total volume. Water content is ratio of weight of water to weight of solid. One thing we have to keep in mind here, that is void ratio is the ratio and rest other features are the percentage. Okay. Moving on to our next definition, that is degree of saturation. It is ratio of volume of water to volume of void. Percentage air void, that is volume of air upon total volume. Air content, that is volume of air upon volume of void. Moving on to unit weights. First of all, bulk unit weight, it is total weight upon total volume of soil. Solid unit weight is weight of solid upon volume of solid. Unit weight of water is weight of water upon volume of water. Dry unit weight is weight of solid upon total volume. Saturated unit weight, that is weight of saturated soil upon total volume. Submerged unit weight is weight of submerged soil upon total volume. If you want to determine the density here, then we have to replace this weight by mass. Now, specific gravity, there are two types of specific gravity. One is gamma s upon gamma w, and another one is bulk unit weight upon unit weight of water. This is unit weight of solid. Okay, now relative density. Relative density is E max minus E upon E max minus E min. This is just the formula. E is the natural void ratio. E max is maximum void ratio which can be in the soil. E max minus E min is the minimum void ratio. Now relative density, we have different properties of soil according to relative density. It is 0 to 15 very loose, 15 to 35 loose, 36 to 65 medium dense, 65 to 85 dense, and 85 to 100 very dense. Now there are few important relations which we have to remind always in our mind. First one is E upon 1 plus E, that is porosity. ES equal to W into G, this is water content. GS is specific gravity. Gamma T equal to G plus SE upon 1 plus E gamma W. Gamma sat is GS plus SE upon 1 plus E gamma W. Gamma D is equals to, this is dry unit weight, which is GS gamma W upon 1 plus E. We can see that S equal to 0 here and S equal to 1 in this one. Gamma D is gamma T upon 1 plus W. Now to determine the specific gravity and water content in a soil, we use picnometer method, which have the formula W2 minus W1 upon W3 minus W4, GS minus 1 upon GS minus 1. This is formula for water content. Formula for specific gravity is W2 minus W1 upon W4 minus W1 minus W3 minus W2. W1 is weight of empty picnometer. W2 is weight of picnometer plus weight of dry soil or weight of moist soil. W3 is the weight of empty picnometer plus soil plus water which is added in the picnometer. W4 is the weight of empty picnometer plus water. Moving on to our next relation, that is shrinkage ratio. It is gamma D upon gamma W, that is V1 minus V2 upon VD into 100 upon W1 minus W2. We can see what are these terms in the graph. That is, when we increase the water content, the volume is also increasing, and in this one we have V1, V2, W1, W2, and this is VD. that is dry volume. Now we have consistency index here, IC, that is WL minus W upon WL minus WP. P is the plastic water content at the plastic limit, WL is water content at the liquid limit, and W is the natural water content. Now liquidity index is W minus WP upon WL minus WP. Toughness index is IP upon IF. IP is WL minus WP, that is water content at liquid limit and water content at plastic limit. Sensitivity is the ratio of QU undisturbed upon QU remolded. Now thixotropy. Thixotropy is the property of the soil due to which loss of shear strength on remolding can be regained. Now next is our activity. Activity is ratio of IP upon percentage of clay size particle less than 2 micron in soil. Now activity limits are less than 0.75 is inactive soil. We can regard kaolinite as inactive soil. AC 0.75 to 1.25, it is normal active. We can regard illite as normal active soil. AC greater than 1.25 is called active soil, which is montmorillonite. Now classification of soil by ASTO, we have group index values 0.2A plus 0.005 AC plus 0.01 BD. This formula is very important in soil mechanics. Okay. Now what is A? A is percentage of soil passing 75 micron sieve minus 35. Its limit is between 35 to 75. This is percentage of soil limit, and the limit of A is 1 to 40. Now limit of B is from 1 to 40, but it has the same percentage of soil passing 75 micron sieve minus 15. C is liquid limit minus 40. Its value of liquid limit ranges between 40 to 60, and value of C lies between 1 to 20. D is IP minus 10, that is plasticity index minus 10. Its value of IP lies between 10 to 30, and value of D lies between 1 to 20. Next is our index properties of soil. Now in this, first one is grain size distribution. According to different sizes, we have different classification of the soil. First one is greater than 300 mm, that is boulder. 300 to 80 mm cobbles, 80 to 4.75 gravel, 4.75 to 2 mm coarse sand, 2 mm to 4.475 mm medium sand, 0.475 to 75 micron, that is fine sand, 75 micron to 2 micron it is silt, and less than 2 micron is the clay. These two are called fine grained soil, and other rest gravel, coarse sand, medium sand, and fine sand. These are called coarse grained soil. Now we define the characteristic of soil by the two ratios, which are coefficient of uniformity and coefficient of curvature. Coefficient of uniformity is D60 upon D10, that is the size of the particle which lies at 60% passes of the sieve. Now this is very familiar term. The rest are the similar one, D30, D60, D10. Now Cu, value of Cu equal to 1 is uniform graded soil, Cu greater than 4 is well graded gravel, Cu greater than 6 is well graded sand. Now value of Cc when lies between 1 and 3 we regard it as well graded soil. Okay, now moving on to consistency limits. First one is plasticity index, which we have discussed earlier, is WL minus WP. Liquid limit is determined by Casagrande apparatus. Now flow index, it is ratio of W1 minus W2 upon log base 10 N2 minus log base 10 N1. Classification of fine grained soil. This is a very important graph. This is a graph between plasticity index and liquid limit of the soil. If IP is below this A line, we call it as silt of low plasticity or organic soil of low plasticity. If it's above A line, we call it as clay of low plasticity. When liquid limit is between 35 to 50 and the plasticity lies below A line, then this is silt of intermediate or organic of intermediate plasticity. If plasticity index lies above A line, then it is called clay of intermediate plasticity. Liquid limit greater than 50, silt of high plasticity or organic soil of high plasticity, and clay of high plasticity lies above A line. Now the formula for IP at A line is 0.73 WL minus 20. Okay. Next topic is our soil compaction. This is a very important graph in soil compaction. With increase in optimum moisture content, we increase the gamma D, that is dry unit weight value, and this is optimum moisture content, which you can see in the graph. Now, soil compaction is performed by SPT, that is standard Proctor test. In this we use the weight of hammer as 2.495 kg, volume as 944 cc, height of fall is 304.8 mm, 3 layer and 25 blows each. In modified Proctor test, we have weight of hammer as 4.54 kg, volume is 944 cc as the same as that one is in SPT. Height of fall is 457.2 mm. We have 5 layers, 25 blows is done in each layer. According to IES code, we have two types of compaction test. First one is light compaction test, second one is heavy compaction test. In the light compaction test, we have weight of hammer 2.6 kg, in heavy one we have 4.9 kg. Height of fall is 310 mm in light compaction and 450 mm in heavy compaction. Volume is 1000 cc in both. We use 3 layer 25 blows each in light compaction test. In heavy compaction we use 5 layers and 25 blows each. Compactive effort, that is 593.01 whole kilojoule per m3, and in this one in heavy compaction test we have effort of 2708.88 kilojoule per m3. Next topic is effective stress, capillarity and permeability. Total stress equal to gamma Z. In this, gamma may be saturated unit weight or bulk unit weight. Z is the depth at which we determine the stress value, and U is pore water pressure, that is gamma W, unit weight of water into Z, and effective stress is the difference between total stress and pore water pressure. Okay. Now, in case of the upward flow condition, we come to a situation where this value is Z gamma submerged minus IZ gamma W, in which I is the hydraulic gradient, I is the ratio of total head loss moving through the height H and upon H, that is the height H. Okay, I equal to H upon H. Now, quicksand condition. Quicksand condition occur in this soil when when effective stress becomes 0. ICR is the ratio of gamma submerged upon gamma W equal to GS minus 1 upon 1 plus E. We come to this formula by just putting the value of gamma submerged upon gamma W. Okay, this is our coefficient of permeability, which determines the velocity of flow of water in the soil. Now, determination of K. We have different tests to determine K. One is laboratory test and another one is field test. Okay, in the laboratory we have two tests. One is constant head test, other one is falling head test. Constant head test, we use the formula QL upon AH, in which Q is the discharge flowing, L is the length of this soil, A is the cross section area, H is the total head loss. In the falling head test, we have K equal to AL upon AT log of H1 upon H2. In this, we allow the flow from H1 height to H2 height while passing through the sample of L length. A is the cross section area of this tube in which we fill the water, and capital A is the cross section area of the soil. Now we have field test. First one is for unconfined aquifer. In this, there is no confinement in the aquifer. This below one, this is the hard stratum. This is the water level. Okay, and this is the soil, top layer of soil. This is our well. This is the drawdown pattern. S1 is drawdown at distance R1 and S2 is drawdown at distance R2. H1 is difference between this H and S1. So we use the formula here at K equal to Q log E R2 by R1 upon pi H2 square minus H1 square. Next one is confined aquifer. It is similar to the unconfined aquifer, but this confinement makes it different. This is the pervious layer of depth D. Rest other terms are same. Now, confined aquifer, K equal to Q log E R2 by R1 upon 2 pi D H2 minus H1. Now moving on to factors affecting coefficient of permeability. K, we use Kozny-Karman equation to find out the factors affecting K. This is 1 upon Cs gamma W upon mu 1 upon SA square E cube upon 1 plus E. Cs is shape factor coefficient, gamma W upon mu. In this mu is coefficient of viscosity and gamma W is unit weight of water. SA is specific surface area, E is void ratio. Now next formula is Allen-Hessen formula to determine K. This is C D10 square. In this usually we put value of C as 1, D10 is kept. Next formula is Allen-Hessen formula, K equal to C D10 square, in which K is in centimeter per second, C is 1 and D10 is in mm. Now consolidation equation, K equal to CV mv gamma W. Now for stratified soil, we have coefficient of permeability in horizontal direction and vertical direction given by these formulas. In horizontal direction we use arithmetic mean, and in vertical direction we use this type of mean, which is h upon h1 upon k1, h2 upon k2, h3 upon k3 up to hn upon kn. Now we will come to know that this h is the sum of all the layers thickness, and one thing which we have to keep in mind that kh is always greater than kv. Next is our seepage through soil, Q equal to kh nf by nd, in which h is the difference between h1 and h2 height in the dam, and f is number of flow line, nd is number of equipotential drops, and k is the coefficient of permeability, q is the seepage flow discharge. Now vertical stresses is our next topic. We determine by vertical stress due to concentrated load. First one equation to determine the vertical stress is Boussinesq equation. We have sigma z equal to 3q upon 2 pi z square 1 upon 1 plus r by z ka whole square raised to the power 5 by 2. Tau rz, that is shear stress. This one is 3q r upon 2 pi z cube 1 upon 1 plus r by z raised to the power 5 by 2. Next one is our Westergaard equation, which we use in this topic. Sigma z equal to q upon pi z square 1 upon 1 plus 2 r by z to whole square raised to the power 3 by 2. Under circular load, we have different equation as sigma z equal to q into 1 minus 1 upon 1 plus r by z whole square raised to the power 3 by 2. Sigma z equal to 1 minus cos cube theta into q. Okay, you can see this theta here. This angle is 2 theta and theta will be half of this angle. Next topic is our compressibility, and this is total settlement in the soil, which is the sum of immediate compression, primary consolidation and secondary consolidation. Primary consolidation, we have the formula here for it, Qn b 1 minus mu square upon E IF. If you are familiar with all these terms, that is Q is the discharge, B is the width, mu is the Poisson's ratio, IF is the influence factor, E is the modulus elasticity of soil. Now for primary consolidation, we have the formula of mv delta sigma h. mv is the coefficient of volume compressibility, delta sigma is the change in the effective stress, and h is the thickness of the soil layer. Now we have different formula for air. When we put the value of mv, delta sigma and h, this formula comes out to be cc h naught upon 1 plus e naught log base 10 sigma naught plus delta sigma upon sigma naught. Okay, next is we come to know about compression index. Cc is E1 minus E2 upon log base 10 sigma 2 minus sigma 1, which we represent in this graph, that is E1 E2 and log sigma 1 and log sigma 2. Cc is 0.009 WL minus 10. Coefficient of compressibility AV is the ratio of delta E upon delta sigma bar, that is change in void ratio upon change in effective stress. Coefficient of volume compressibility, it is ratio of delta V upon delta sigma, that is change in the volume, ratio of volume change upon change in effective stress. Now we have different form of it, as we can represent is by AV upon 1 plus E naught or delta E upon 1 plus E naught upon delta sigma. In consolidation, we have a time factor equal to CV T upon V square. CV is coefficient of consolidation, T is the time taken for the consolidation, H is the thickness of the layer of soil. Now for U that is consolidation less than 60%. When consolidation percentage is less than 60%, we have tau v equal to pi by 4 u square. For consolidation greater than 60%, we have formula of tau v as 1.781 minus 0.933 log of 100 minus u. U is the percentage of consolidation. Next topic is our shear strength of soil. In this, we have shear strength formula as C plus sigma tan phi, in which C is the cohesive strength of soil, sigma bar is the effective stress, and phi is angle of internal friction. We have a formula here as sigma 1f. This is the formula which we use in the triaxial test apparatus. Sigma 1f is sigma 1f. This is equals to sigma 3f. Tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. Next topic is our stability of slope. In this topic, we have to determine the factor of safety for the failure of the sloped soil mass. Now, see, this is factor of safety is tau f upon tau. This is shear strength as failure. This is equal to C plus gamma dash z cos beta tan phi upon tau gamma dash z cos beta sin phi. In this, beta is this slope angle, z is this depth or we can say height of this soil, C is the cohesive strength of soil, and gamma dash is the unit weight of this soil. Next is Taylor's stability number Sn. This is the ratio of cohesive strength upon Fc. This is the ratio of cohesive strength upon Fc gamma h. H is the thickness of soil layer, gamma is the unit weight, and Fc is the factor of safety with respect to cohesion. Next topic is which is the last topic I think in soil mechanics, that is earth pressure and retaining wall. Away from the soil we have active earth pressure, and towards the soil we have passive earth pressure. The formula for these two are active earth pressure equal to Ka sigma z minus 2c root Ka. Passive earth pressure, this is Kp sigma z plus 2c root Kp. Ka is 1 minus sin phi upon 1 plus sin phi, Kp is 1 plus sin phi upon 1 minus sin phi, where phi is the angle of internal friction of the soil layer. So friends, in the next video we will have a quick revision of foundation engineering. Thank you friends, goodbye, and don't forget to subscribe our channel.